I've been building industrial internet solutions for about 15 years, and my topic is going to share how business value can be created by putting PackML into the cloud. But before I do that, I want to share some big numbers with you. In a recent report from McKinsey Global Institute, they say that if policymakers and businesses get it right, linking the physical and digital worlds could create up to $11 trillion per year of economic value by 2025. Wow, 11 trillion, that's a huge number. But where's all this value coming from? Well, in the same report, McKinsey shows that the setting that creates the most economic value from the Internet of Things is factories. It's not smart streetlights in cities. It's not refrigerators that order their own milk. It's not wearable t-shirts that measure your heart rate. It's factories. So what that means is that we are here sitting on top of the largest setting of economic opportunity of the Internet of Things. That's pretty exciting. But also in the same report, McKinsey has a little bit of a warning. They say that interoperability between IoT systems is critical, and it's required to unleash 40% of that economic value on average and up to 60% in some settings. So that's where PackML comes in. Interoperability is loosely defined as the ability for computing systems to exchange and understand each other's data. And PackML gives us a way to exchange and understand the data from different machines. So it has that key role with the Internet of Things. So in my topic today, I want to talk about how PackML's common description of machine states and modes transmitted with pack tags gives cloud solutions in the IoT the ability to compare apples for apples, do benchmarking, and lead to big data analytics. I'm also going to share with the fact that PackML is not just an Internet of Things solution. As you saw from the previous two presentations, PackML has a very good, strong, compelling ROI for in-the-walls reasons. So in a way, if you put PackML into your factory, you're future-proofing yourself to have the ability to join the IoT and gain those benefits of big data when you're ready. And then finally, it's those big data benefits. That's where the economic benefits come from. Big data, being able to benchmark machines, and from those benchmarkings, understand which machines run well, which don't. From understanding that, define predictive models. From predictive models, provide prescriptive services so that uptime and availability can be increased, boosting the productivity of the factory. That's what PackML can do when it's deployed in the cloud. So just so that we're all on the same page, and I know we've already seen it, but PackML is really transmitting, if you're integrating machines, if you want to put a line together, you can use PackML to integrate the states and the modes of the machines by exchanging pack tags. PackML as a standard defines those pack tags, but PackML uses other standards. PackML works really great with OPC UA. If you have OPC UA, you're defining the context and the structure of the data words that move the pack tags around. And OPC UA rests on top of yet another standard. Ethernet is defining a network, enabling digital communications to occur between the machine controllers. So those three standards work together to enable the line integration on your factory floor. But those same three standards can bring data from the line up into the cloud. With existing technology, it's possible to use Ethernet, OPC UA, and pack tags to bring data outside of the walls of the factory through secure networking methods securely out onto the internet, where on the internet data collectors can operate and gather the data. The data can then be put into private and public clouds where data from many machines coming from many different customers in many countries on different continents can all be brought together. And with that big data, then sophisticated applications can do the analytics, where data is converted into actionable information. This actionable information can then be disseminated to the authorized users in the form of web pages, dashboards, reports, mobile apps, and RESTful APIs to exchange the data with the right people, the right systems at the right time. So, look at an example. Let's say you have this machine, it moves packages around, you've implemented it with PackML, and with PackML, through the pack tags, you're able to understand how much time it spends in execute, how much in held, how much in suspend, and from that you can create an OEE profile. You can understand how the machine is running, how it's run in the past, you can see its trend. And that's very valuable because this is what the data you need to manage the machine. But if you have 3 machines also on the same plant floor, it's great to be able to compare, because what you want to do is you want to measure to manage, use data to make decisions. And so by knowing if a machine is stopped or if it's running poorly, you can then do a Pareto analysis. And with Pareto analysis, as Six Sigma practitioners know, that's how you identify the best return on investment of your resources. If you use the largest reason for unplanned downtime, and you spend your time and energy reducing that, that's going to probably give you the strongest return on investment. So this works great, and it's already being done by many organizations inside the walls of their company. But now, imagine if you were to do this around the world. If you could have that performance data from machines running in different customers on different continents, well, an OEM who builds these machines could have the ability to spot isolated instances at remote and different facilities where there might be some common thing that goes wrong with the machine. The OEM can then learn from those isolated instances, and from those learnings can develop a proactive support where parts are dispatched or service technicians can connect through secure tunnels and can upgrade the software. Well, with a solution like this, now everybody who owns the machines from this company, even if they haven't even ever had a downtime, they can enjoy the benefits of a predictive support solution because they were sharing their data about their machine operation, and in exchange, they have a proactive service being delivered by the OEM. And of course, with the OEM, if you have, whether it's dozens or hundreds of machines at the same time out in the field, you can very quickly get thousands of machine years of experience. And these thousands of years of experience can lead to very accurate predictive models. These predictive models can then be used to do predictive maintenance solutions. So with this type of support, an OEM can offer to his customers the ability to understand where that customer's machine is with respect to its peers in the same company, its peers in the same country, or all around the world. Having this information gives the ability to develop these predictive and proactive support services. So PackML provides interoperability, and that interoperability, I think, is really good inside the walls. It has a clear and demonstrated ROI. It shortens the startup. It simplifies the machine operation, makes it easier to train. It makes the code modular, easier to deploy. So those are all really good reasons. But PackML in the cloud has great advantages. You can standardize your data, and with that standardized data, describe and benchmark machines. From the benchmarking of the machines, you can understand which ones don't run well. From the understandings of the ones that don't run well, you can develop predictive models. Modeling the behavior can lead to predictive maintenance systems and proactive support services. So that's how I see that PackML in the cloud can enable us all to be on our way to enjoy the benefits of the IoT. So at the beginning of this presentation, I mentioned the McKinsey number of $11 trillion per year, or almost $4 trillion per year of economic value in factories. So I'm going to challenge you all. What's your share going to be? Because if it's trillions of dollars at stake, there's billions here in the packaging industry to be had, and millions for the companies that get it right. If you're interested to do this, I have 2 thoughts to share with you. One is use PackML. And if you want to use PackML, the best place to start is OMAC. OMAC has lots of tools and resources, as Brian shared, that can help you get started quickly and effectively to use PackML. 2 is the stakes are high and these solutions are complex. If you want to put a system online on your equipment or in your factory, I recommend finding a partner company, a company that can help you take everything from the machine through to the cloud with private secure networks, data warehousing, applications, and alerts that can bring you the information that you need. And so with those two strategies, you can save time, because you can take advantage of systems that have already been developed. You can save money, and you can reduce your risk. So thank you very much for your time. I just want to say I'm really glad EI3 is a part of OMAC. OMAC brings the right companies together, both machine builders, machine owners, and technology providers, to have a very lively dialogue. And in that lively dialogue, we can develop standards like PackML that enable you to have benefits for your machines for today, but also help to develop the standards to benefit you in the future. Thank you very much for your time.